And here was that reducing DC current can eliminate or significantly reduce pores in copper, but impact productivity. That's a very simple diagram just for demonstration purposes. Once the diagram is built, and the way how it's built, it's there are special here, for example, let's, for example, the connection looks like that. For example, removing electrolyte from the pores counteracts electrolyte trapped in pores. Based on this, there is a button that automatically generates directions from this diagram. Usually, there are three types of boxes, so there are three templates. It's all programmable, although it's quite a smart way that the software reads the diagram and creates problem statement. For each useful function would be find an alternative way to obtain reducing DC that offers the following: eliminates, reduce, or prevents pores in copper, and does not influence the productivity. For harmful will be find, for example, a way to eliminate, reduce, or prevent electrolyte escapes from pores in order to avoid spots on the surface on the condition of electrolyte trapped in pores. Actually, each problem statement, it's a mini problem in tradition of ARIS. After that, we can you can contradiction, find resolve the contradiction. Reducing DC current should be provided to counteract pores in copper, and shouldn't be provided to avoid the counteracting productivity. So that's all automatic. And now they could be read here, or they could be selected all and submitted in the report. So this is these problem statements are submitted in the report, and there is an additional option. For example, if I click on the problem statement, it offers me the operators to work with. For example, counteract the harmful effect, protect, and all of that. But it also has an option, what we call refine. And if I press it, it provides some more precise, we call them refined direction, more precise. For example, find a way to remove or modify the source of electrolyte escape from pores, find a way to counteract electrolyte escape from pores, and usually they could select it here and submit it in the report. Here I have done it only for the contradiction. And with the contradiction, its refined direction will be try to provide reducing DC at one zone and not to provide at another. Try to provide reducing DC at one time and not to provide at another. Try to provide reducing DC at one condition, not in another. This is the separation, basically the separation principle. This is for the short brainstorming, but we don't want to go into the operator, because work with operator is the most time-consuming work and sometimes boring work with finding a solution. But in this case, try to provide reducing DC zone in one time and not to provide it at another, actually led to the solution to this problem, which is conduct the whole, almost all process of deposition of copper at a high current, and only at the end to create a thin layer of copper that will basically seal the pores. By the way, when we loaded the problem statement in the ChatGPT, one of the solution was sealing the pores.